Hey guys, in this video I'm going to be show you how to represent alkanes, alkenes and alkynes in one general formula. So in class 10th we have learned that the general formula for alkanes is CnH2n plus 2, and for alkenes it is CnH2n, and for alkynes we have CnH2n minus 2. But what happens if we have a double bond and a triple bond, or more than two number of double bonds or triple bonds? In such combinations, there is one general formula which we can use for chains, for branches, for alkanes, alkenes and alkynes, as long as it's not ringed. If this is a ring carbon chain, then this formula won't work. Then there's a separate formula. So the formula is CnH2n plus 2 minus 2x minus 2y. Now what are x and y in this formula? So x is the number of double bonds present in the chain, and y is the number of triple bonds present in the chain. So I'm going to show you some examples where we can verify this formula. So in this example, I have taken a long carbon chain that has 3 double bonds and 1 triple bond. So of course we can't use any of the direct formula for alkane, alkene or alkyne, but if you have to calculate the number of hydrogen without actually making the structure, then you can directly use the formula. But first we are going to count the number of hydrogen. So there are 9 carbon, as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the number of hydrogen are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So the formula for this one is C9H10. And if you use the formula that I have given, it says CnH2n plus 2 minus 2 times the number of double bonds minus 4 times the number of triple bonds. So if you substitute the value, we get C9H18 plus 2 minus 2 times we have 3 double bonds, so it becomes 6, minus we have 1 triple bond, so it becomes 4 times of 1, that is 4. Now you can clearly see that it's C9 and H10. I'm not gonna calculate and show you. So here is another example where we have a long carbon chain, and here I have taken 2 double bonds and 2 triple bonds. So if we count the number of carbon and hydrogen, what we get is C10H10. And if we use the formula, we have Cn, and that is 10, H 2 times n 20 plus 2 minus 2 times of the double bonds, that is 4, minus 4 times the triple bonds, 8. So if we find it out, we get C10H10. So this again proves that this formula holds good for all carbon chains as long as it is not branched. For branches, this formula won't work. If you want to know where this formula derived from, then I'm going to show you how I derived this formula. So let's take a 2 carbon atom compound. Let's say ethane. So the number of hydrogen in this is clearly 6. We have C2H6. But what if there's a double bond? It becomes ethene. So it is C double bond C, and the number of hydrogens is C2H4. And if we have ethyne, C triple bond, then it becomes C2H2. So if you clearly see, it is first 6, then 4 and then 2. So what has changed is the number of double bonds and the triple bonds. So when we add one double bond to a compound, the number of hydrogen becomes minus 2, reduces by 2. And when you add a triple bond from ethane to ethine, the number of hydrogen reduce by 4. So just by applying unitary method, we know we will consider every carbon compound as an alkane. So we have CN H2N plus 2. And now whatever the number of double bonds it is, we are just gonna subtract 2 times the number of double bonds. Why? Because each time we add a double bond, the number of hydrogen atoms reduced by 2. And what about the triple bonds? We are going to subtract it by 4. 4 times the triple bonds. Because just now we saw that the number of hydrogen reduces by 4. So in this case, we just applied unitary method and we got a formula that we can use for, all alkanes, alkenes and alkanes.